There are dozens of theories about the origin of the Earth. In general, the theories of the origin of the solar system or Earth can be divided into two groups: 1. Evolutionary theories. 2. Catastrophic theories. Evolutionary theories. The theories which suggest that planets are formed during the evolution of the Sun are called evolutionary theories. The nebular hypothesis is an example of these theories. Catastrophic theories. Catastrophic theories are those which imagine that planets are formed by some special accident or catastrophe, such as the close approach of two stars or by the collision of two stars. However, as the stars are so far apart in the galaxy, the possibility of such a catastrophe is extremely rare. Examples of catastrophic theories are the planetesimal and gaseous tidal hypotheses. The best-known hypothesis for the origin of the Earth and the other planets of the solar system are as follows. Nebular hypothesis. The nebular hypothesis was put forward by Kant, the German philosopher, in 1755, and Laplace, the French mathematician, in 1796. This hypothesis suggests that the Sun and planets including the Earth have formed from a disk-shaped rotating nebula. A vast cloud of hot gas is called nebula. Planetesimal hypothesis about the origin of the Earth. The planetesimal hypothesis was proposed by Chamberlain and Moulton in 1904. The main points of the hypothesis are as follow. The Sun existed before the formation of the planets. A large passing star approached very close to the Sun. Due to the disruptive forces of the Sun and the strong gravitational pull of the passing star, giant masses of gas were torn from the surface of the pre-existing Sun. The giant mass of the gas broke into a large number of small chunks which on cooling gave rise to solid particles, called planetesimals. The planetesimals started flying as cold bodies into orbits around the Sun in the plane of the passing star. By collision and gravitational attraction, the large planetesimals swept up the smaller pieces and thus planets were formed. Gaseous tidal hypothesis. This hypothesis was proposed by Jeans and Jeffreys in 1925. The gaseous tidal hypothesis may be summarized as follows. A very huge star progressively approached the Sun. Due to the gravitational pull of the star, a gaseous tide was raised on the surface of the Sun. As the star came nearer, the tide increased in size. When the star began to move away, the gaseous tide was detached from the Sun. Its shape was like a spindle, being the thickest in the middle. The spindle-shaped gaseous mass soon broke into 10 pieces, 9 of which condensed into planets, and the remaining one, which further broke into small pieces, formed the group of planetoids. Rotational and tidal theory. A scientist named Ross Gunna put forward this theory, which is termed as rotational and tidal theory. Actually, this theory is a combination of the basic principles contained in the theories of James Jeans and Laplace. According to Ross Gunna, a large star approached a fast rotating star. As a result, tidal action deshapped both the stars, which separated later on, leaving behind a mass of tidal protuberance. Planets were formed from this mass. Professor Banerjee has disagreed with Ross Gunna's theory that a star can approach a fast-moving original star, Sun. Binary star hypothesis. This hypothesis was proposed by Lyttleton in 1938. Before the formation of planets, the Sun had a companion star. Another star approached close to these double stars and dragged the companion star away. A gaseous filament was torn from the companion star and it remained close to the Sun. The planet was originated from this gaseous filament in the same way as described in the gaseous tidal hypothesis.